All right. I wanted to talk a little bit about developing wallets. Now, we just wrote a wallet some months ago. I don't know the exact time, but I'm sure that I will see shortly. And, if you write your own wallet from scratch, you'll learn a lot. So I wanted to set aside some time to talk about how to build a wallet, the kind of functions you're going to need to implement, and some of the lessons we learned. So this is our old wallet. It's called the Decilium wallet. What we use this wallet technology for is for signing messages on your computer away from the server, creating private and public keys. And what's interesting about the Decilium protocol is it's not based off of an existing protocol out there. It's a whole new L1 network with new technology. It's not forked from Ethereum. It's not forked from some other place. It's actually derived from my master's research. So it's a whole new thing, and because of that, we had to make our own wallet. We learned a lot of lessons. This is a good version one wallet. It's got a lot of problems, but we learned a lot, and so let's dig into it and talk about kind of the most interesting parts. So to me, the coolest and most interesting part of the wallet or any wallet is the crypto module. I was when I first wrote this, I guess last October, or committed it. That's not when I wrote it. When did I write this? Let's figure it out. Okay, last June. So when I first wrote this around last June, I didn't really know which libraries to use, and it can be very overwhelming to pick up a bunch of crypto libraries. So if I could start over, I wouldn't have chosen these libraries. But if it's your first time writing a wallet from scratch, I think Python's a good language, and I think the cryptography library is good. But I really did like the experience using the ECDSA library, because it was really easy to get my head around the crypto concepts in a way that was very high level. Now, I wouldn't suggest going to production with this library for very long. I think it's fine. I think it's secure enough for like a version one of something, but it has serious limitations because of the lack of control you have over how keys and things are generated. There's some custom stuff in here, well, specifically our get pass module, but most of this, someone should recognize. And I think that's also an important principle. If you're developing a wallet, when you're setting up your dependencies, you want to make sure that, you're picking a small set of core dependencies, ideally ones that are built into language. And if you're really hardcore, you probably want almost no dependencies at all. You just want to use some math and write everything from scratch. But unfortunately, people have jobs, people have things to do, so you don't have time to do everything from scratch all the time. Yeah, okay. So right away we have like a convenience class. Yeah, I don't want to actually dig into this too much. This is not the most beautiful class and set of functions here. But what we're doing here is, when you encode data, a lot of times you get date objects. Date objects are notoriously annoying to deal with. So all we're doing here is we made a little special JSON object. So sometimes we're dealing with data, we want to turn it into a string, and we also want to represent dates well. So this little chunk of code here ensures that we can always serialize and deserialize date strings, which is super important. If you have just that problem on a project where you have a bunch of JSON that has dates inside, I could probably clean this little chunk of code up, but I've lifted this between so many projects now. It's kind of insane, and it's actually very robust for how small it is. Okay, let's get into the crypto class. So the crypto class is certainly going to be the core of any sort of system that you're going to write, any wallet. So let's go through some of the most interesting / difficult parts. So if you're going to generate a user, there's many ways and many libraries to do this. What we did is we just set our own version. So version control is important here. You're going to have people with older wallets. You're going to have people with older technologies. So we basically said, hey, this library is going to generate keys of a specific version. We're calling it Python ECDSA 0.1. The reason we attached this and put this in all our wallets is because in 5 years or 10 years from now, we still need to support this technology. So this means on the server or when we store the user, whatever wallet we write in the future probably has to have this class and this code around it somewhere to deal with older keys. So we label it. That's very important. You don't just want random keys flying around without a version. And we know when we see Python ECDSA01, we know it was generated by this code, and so we know how to deal with that key. You'll notice in every cryptography language out there that there's usually some sort of key version. It's for this reason. Here we generate both the public and private key. And in our case, we actually generate an address. We follow the Ethereum standard where we take the last 42 bits and then we return back the public key. We return everything back as hex because we intend on turning this into JSON eventually. And we call this a user. There's some things I regret, like I regret calling this the API key because I was thinking in a very API centric way. I didn't include address until later, so the whole system right now, the whole actual chain that we're developing is centered around this thing called API key. But I'm realizing that people might want to change keys. So one of the situations we have recently got ourselves into is that we need to everywhere in the whole miner, we have to upgrade API key to deal with addresses and allow for a plurality of keys. So if I did this in the future, I would allow a one-to-many relationship between users and keys. Anyway, there's a whole conversation here, but I guess if you're generating users and you're thinking about developing your own wallet, put a lot of thought into the relationship between users and keys, if you want many keys per user or not, and what the trade-offs and benefits of both those approaches are. Ethereum, for example, in general, basically your user is your key. So it's very, very simple. We started with that assumption and realized that in some situations it's very limiting. Imagine you have a private key. You're going to need a function that, given your private key, you have to actually recover their address. So that's what this function does. This, of course, I don't know if I explicitly said this, but this is open source. You can just download this code and use it and hack it, and both host websites and do whatever on Decilium, or just take this and use it on your own projects. We have a sign request message. So aside from generating a user and a public key and private key, you'll also need the ability to sign requests. So you might have some giant message. In our case, it's always going to be a JSON message. What we do is we have our special do encode string method that actually just wraps our dictionary method up there. And then what we do is, I don't want to dig into the details, but we basically unpack and sign and create a representative string of that object. And then we sign it digitally using the ECDSA library. And then we actually package up signatures. Now, there's support here to have multiple signers on a message. In practice, we've only ever used one of them. So we have this notion that there might be a list of signers signing a message. In practice, structuring, I've been working a lot with Wallet Connect recently. Structuring a protocol where you can pass a message around 10 people to get them all to sign it, good luck making that protocol. It's probably a nightmare. So in practice, one signature is enough, but we do support multiple signatures, and this is one way you can do that. In the same way, you might be on the other end of this process and you might receive a message. You want to verify that it's a correct signature. So we do that here. And this actually goes through a message, looks in the signature array, and then actually checks if there's a valid signature for all of the public keys listed. Then we have some convenience methods around decode and encode. So specifically, this is for Cypher. So if I have a secret message I want to send to someone, I might want to encode it with my public key and then decrypt it later. So all of these methods deal with that. And I actually forget now. I think the way I coded these in the first place, now that I'm looking at the crypto library, it looks like I'm encoding and decoding with a supplied password here. I understand that, but I haven't looked at this code, as you've seen, since October, and I am wondering what this encode and decode key is. I'm passing in a key. I don't know what I'm doing. Okay, I don't want to look at this now on a video, but anyway, you could read my old code if you want and tell me what the heck I'm trying to do there. I remember there being a good reason I had to make the encode key method, and I have no idea what it is. And I see that the code is different. Okay, this is a straight up encode with oh, that's decode. I was getting a little confused. This is a straight up encode of the content with the key. Where's the key come from? Oh, the key comes from... Okay, so I hash it to get a key. Okay, got it. Random salt. All right, I should be able to pass it. Okay. Yeah, I don't know. I think it's just the way I'm deriving the key is different. It's based on the password. They're both based on the password. Yeah, I don't know what the difference is here. And I've fully distracted the video, so let's get back on track. Sorry about that. I will do better. So that's the crypto module. So all of that was a deep dive into the crypto module specifically. So now we can do interesting things. Like we know that with a little bit of code, not too much in the way of imports. This is also like it's a little bit of a sexy library because it's only 150 lines of code. So that's nice. Like it's not complicated. It's beginner friendly. I will probably refer to this thing in the future when I'm trying to cover my bases when doing a wallet, because this is actually fully functional. We use this today for all of our messages. So it's pretty good. And now someone's going to come hack us to break it, right? To prove a point. Anyway, so zooming back out, that's just the signing and dealing with messages, but that doesn't actually help us do any work. So there's actually other problems that we have to take on here. Specifically, we have to like send the messages somewhere. We have to sign messages that are coming through. So there's a dumpster fire of a file here we can jump into, which has been patched so many times that it's got to be rewritten. So we will rewrite it. But in the spirit of, hey, here we are, this little baby has existed since 2016. You can take it, destroy it, do whatever. But this Decilium API is how people connect to the remote servers, and it does everything from submitting API requests to cleaning data and all sorts of other things. So I'm just going to highlight a couple interesting parts of this file. So this is essentially an API requester. It allows you to use the Decilium network locally with a thin client. You can talk to either your own node or a remote node. But we're interested in the terrible approach I took, which was a slapping on what I called simple wallet at the end of the API class. I fully intended simple wallet to just be a simple wallet that was going to survive for like 1 month. So I had created the crypto library some time ago, and I was like, great, we need to like actually sign every transaction as it's going to Decilium. I'm just going to make a simple wallet, and I'll come back next week and make a better wallet. So I wrote this wallet in like a day, and it's still like literally the wallet we use today. It's terrible, but it's also like the crypto library, very, very simple. So let's talk through what this simple wallet is. So yeah, it's a simple wallet for holding Decilium network artifacts. This wallet is a code level wallet only and does not have a GUI for user interaction. Volunteers are presently working on hardware, JavaScript, and GUI wallet implementations. They didn't, but that's okay. Why? We had a lot of problems in Web3 with issues like signing transactions, storing accounts, so blah, blah, blah. So before we had this crypto module, and you'd have to actually write a script if you want to do an API request, to create your API request, prepare it as JSON, then sign in. It was just like such a cumbersome process that we actually created this wrapper class for us. It's worth looking at the code. No, it's not worth looking at the implementation first. So this little puppy actually does a lot. It's actually like quite the workhorse. Although it's simple, it's very functional, meaning it's responsible for loading files, like loading wallet files, managing secrets, like secret data within the file. It opens files that are encrypted, it decrypts them into memory, so that's insecure, and it manages the wallet in memory, and then handles whatever requests, and then seals everything up. So everything on the hard drive is secure. The data is exposed in memory, but it never stores any data in plain text and I believe if this is true of this version, does not print out to any sort of standard out any sort of compromising information. But the ideal place for this class would be on some sort of embedded device, not say running on like a server somewhere running on your laptop. But you can totally run this on your laptop or wherever you want if you're a cowboy. So let's go. So the load function does what you might expect. A wallet is just a dictionary object. And all we do here is we actually grab a file from a read path in Python, and we actually use that decode string method to actually convert it to a string. And then we use our decode method after it's a string. And if we have a password and it's password protected, and we assume it's our one supported version, and we decode that into the wallet. If it doesn't work, you get an exception. So there's no real, this thing dies really quickly if for whatever reason your wallet can't be loaded. The same reverse happens with save. This takes any JSON object that's in the .wallet location, and it encodes as a string and saves it. So here's the fun stuff. There's a stub in here for requesting signatures. For now, because this is we write like local applications that we want to run that runs on the Decilium network. We don't actually send the signature requests anywhere. We just readily sign them. But this would be a hook that you'd implement if you wanted to send a message to the GUI, if there was ever a GUI on top of this puppy that said, hey, someone wants to sign, someone wants to do this transaction. Do you approve? And you could have someone sitting there pressing approve, approve, approve. Because this is a wallet that's intended for people to use in scripts, we make the assumption that we're just going to return true, but that could be updated like literally right here. There's some convenience methods. So we have create user. In the crypto library, generate user, but here we have create account. So what we're talking about with an account is that in your wallet JSON object, we actually want to create an entry for a user. So we're actually using the crypto generate user, and then we assert some basic stuff to make sure it's not deficient, but we really don't assert much about it. And then we populate our account data and save the user. And then there's, various other convenience methods that can work on the data in memory. So if you load a wallet, it ends up in the self.wallet object. And then once it's there, we can do all sorts of cool stuff. So we can list the accounts in there. We can rename the account. We can get a specific account. We can get a user. We can set some secret values. There's all kinds of stuff you can do here. And then lastly, if you just have your private key, you can actually recover your account. Now, of course, it won't recover any of your secrets or data, but it will recover your keys and whatnot. So that's it. That like all of this code. If you were in a situation where someone said to you, you need to write a wallet in the next hour, and it didn't matter what technology you had to do it in, you have my official permission to come in here, grab the simple wallet. You're allowed to have it. Justin said it's okay, and you can also in the code. You can also, where is it? You can also go into crypto and grab crypto, and that's the basics of a wallet. There's a lot more in this repository. Like there's a lot of like really cool utilities. Like we have a utility for taking zip files, breaking them down into like 1 kilobyte chunks, sending them off somewhere to upload. That's for uploading large files. We have a bunch of stuff in here that I think is kind of out of the scope for this video, but I think I covered most of the interesting stuff. There's a JavaScript client, there's a local server. There's also a commands directory with loads and loads of commands that you can use if you are using a command line interface. So the commands include like creating a user, deleting users, deploying a website, deploying a smart contract, not supported for the public yet. It just will tell you no. But if you want to deploy, if you want to experiment with Decilium smart contracts, let me know. You can deploy like DNS entries. You can generate new wallets, generate users, all kinds of stuff you can do. So yeah, feel free to play around. But yeah, that's the crash course on how to create a simple wallet, and the code is here. So have at it. All right, thanks.